This is Twit.
Bandwidth for Know-How is brought to you by CashFly.
This episode of Know-How is brought to you by Automatic, the small adapter that turns your clunker into a smarter, connected car. For more information on their brand new Automatic Pro adapter, visit automatic.com/twit and enter the limited time offer code TWIT20 for $20 off the new device. On today's show,
You'll know how to build your own Arduino picture frame.
welcome to Know-How. It's the Twitch show where we build, bend, break, and upgrade. I am Father Robert Ballas here.
And I am Bryan Burnett.
And Bryan, we haven't done one of these for a while.
I know what you're talking about because there has been a steady stream of know-hows every week that have gone out. So what do you mean we haven't been here?
Well, I mean, because of the space-time slaptinium.
The time paradox.
We've broken that. And I was in Rome for 6 weeks, and I came back, and I have a wicked flu right now. I can barely hear anything you say.
You know what's funny, though, is in your delirium, you don't seem much different.
I know.
You know?
So me being sick is basically me being
pretty normal. Although, yeah, you have been gone for, it was over a month, wasn't it?
Actually, yeah, way more than a month. It was 6 weeks. If you include Make Your Fair, it was more than 6 weeks. It was like 6.5 weeks.
Yeah, well, I missed you, man. It's been a long time.
Hey.
And now I'm infected.
Now you're infected. That's what I like to do. I like to spew my love all over you, Bryan. That's how we do that.
Oh, boy.
Now, we will be doing an episode next Monday on some of the things that I learned about the little trip to Rome. I picked up a few bits of gear that really saved my production life, and we're going to be going over that. But right now, we wanted to do a project that you did for Screensavers not too long ago, and we've had some very good response from the people who have been doing our Arduino 101 projects. We thought maybe we should give them something a little blinkier.
A little art project or something?
Yeah.
Because, the projects we've been working on, we've showed people the basics of, it's like a single LED and then like a strip of LEDs and how to incorporate buttons and stuff. But sometimes when I'm trying to learn how to use, or when I was learning how to use the Arduino, I kind of wanted to set a goal for myself, set a project idea, and then use the things that I'd learned with the LEDs to kind of build something. And that's what motivates me to continue to tweak with the code or add more things to a project. And so what I have sitting on the table here is a little project that I had done for the Screensavers. A friend of mine who Nord Vogel did the artwork of this shark, and I've had it for a long time, and I've always liked the idea. Like, I like the way he painted the light coming in from the surface. Right. I was like, that would be really neat if I could somehow oscillate LEDs to make it look like the shark is underwater. So basically, I took a shadow box, which is lifted about half an inch away from the painting, and then was able to line the edges. And I kind of have it hodgepodged right now because I don't want...
Someone needs a bit more hot glue.
Well, because I wanted to be able to take this apart in case I wanted to change anything in the future, because I wasn't dead set if I was going to continue to use the little Nano for it. And so it's been always a work in progress. Right. But I lined the sides of the picture frame with the LED, and that's what casts the light across the picture itself. And then it's blocked mostly by this little bevel here. And it has the effect that I want, but the code that I have uploaded right now is very basic, pretty straightforward, and it's just cycling through the three colors of, I think it's blue, teal, and basically white.
Yeah, but I mean, that's what we want. I mean, we want something very basic. This is still an Arduino 101 project, and we've been playing with WS2812 LEDs for more than a year now. We've made our little semi-steampunk goggles. We made things like the little Stargate thing that I've got going on in the producer's office. This is just another application for that. I love the fact that you use this little shadow box because it makes it have depth, which is cool. I like that. It's a nice approach.
Yeah, and actually, I pirated your LEDs that you had at your desk.
I saw that.
Because I think what I've realized is it's always nice when you're shooting a video or something, like when we do reviews and things here, or when I do a screensaver review, I like to have color in the background, like you do with your rack space when you're doing reviews and stuff at your place in the city.
Now, Bryan, there is an interesting history to this project because you started working on this when we were at Black Hat DEF CON.
Yeah, I started working on this when we were at Black Hat DEF CON because DEF CON, they have the maker space or the hacker space. And every year we kind of want to go with a little project in mind. I think the first year we went, we did quadcopters and built out some stuff there. And this year I wanted to bring in a project where I got to play with LEDs, but I actually had to leave early, so I didn't get to.
And if I remember correctly, you learned all about voltages.
Oh, that's what you wanted to bring up. I was wondering where you're going to go with that.
So actually, part of this is my fault. So I gave you a strip of WS2812s. Unfortunately, they were 12 volts, so you were running 5 volt into 12 volt, which it
couldn't get it to work. I was like, oh, this is really weird. Like they won't light up. I think I don't have enough power coming from the laptop or something. You're like, oh.
And then I gave you a strip of 5 volt, and you for some reason decided to put 12 volt through it, and evidently those get really hot.
I guess they're not supposed to get hot, are they?
No.
Yeah, what I tried doing was I think I had one of the external batteries, one of the quadcopter batteries that we used, and I plugged that in conjunction with plugging it into the laptop. And yeah, they were
really bright. They were really bright for like 30 seconds.
Really bright for a few seconds, but the code wasn't working, or so I thought, because the colors weren't changing. And then, yeah, they got really warm, and there was kind of like a plasticky burning smell from them.
If you listen really closely, you heard the sound of WS2812 screaming. What do you do? Why do you hate me, creator? All right, so let's go ahead and jump into this. We're going to need a few things. First of all, we've got our bag of Arduinos. We like using the Nano just because they're nice and small, and this is something that you're going to want to squeeze into your picture frame here. Right. Can you actually show us your setup?
The little Nano on here?
Right. So
yeah, sure.
I mean, the strip is inside the picture frame, but then you've got the Nano attached to the side there. Show us how you wired that up.
All right. So at the top, you can see the little Nano. And then you helped me out and gave me one of, it's the voltage regulator. Isn't that what it is? Yeah. The little UBAC? UBAC.
Universal Battery Eliminator Circuit. It allows you to take, I think that one will do between 5 volts and 18 volts, and it will turn it down into any voltage that you want.
Right. So you helped me with that. You soldered it into the ground and power pins on the Arduino, but then you also connected it to little bullet connectors so that we could power the LEDs separately from the Arduino. And but up at the top right-hand corner of the screen there, you can see the little bullet connectors that go to the picture frame.
Right. And the reason why we did that is just because these are a lot more lights than we would typically run off of a Nano.
I think I have 32 LEDs on this setup. What I did was I took a strip and measured it out along the edges, and then just divided how many there were together. So that helped me with my programming.
Right. Okay, so what we're going to do is you're going to be showing them the programming, and I'm actually going to be assembling one of these.
Ooh, okay.
Yeah, so I've got myself my Nano here. This is there we go.
And before you start, though, I mean, usually what we do is we test bench on like a full-sized Arduino. And then once we have everything figured out, then we go to the Nano.
And again, that's what we love about these Arduinos, about the Atmel chipset, because from the small one to the big one, it uses the same programming. Some may have more memory, but we're not really going to be running into that since our programming is so simple. In this particular case, we know it already works, so we're not going to breadboard it. We're not going to do a test on a full-size one. We are going to run lights directly off of this Nano, but then like we did for your picture frame, we're going to give it a separate power source so that if we want to increase the number of lights, we can do that.
Right.
We're going to have links in the show notes. Again, depending on whether you buy a genuine one or you buy a clone, you can find these anywhere from $1 to $20.
Does that say fake Duino on there somewhere?
This is a faux Duino.
Oh, the faux Duino.
Yeah, I will say though, over time we've both of us have seen that the fake Duinos, they don't last as long.
No, they're not as much of gluttons for punishment as some of the real Arduinos are, but But the nice thing is that you can buy them in bulk for cheap,
Right.
play around with them, and if they break, fine. But if you have a project that is sensitive, like if you had an Arduino hooked up to, say, your plant system that was fertilizing and watering it, you probably would want to buy a full-on
You'd probably,
Arduino.
yeah. And actually, Cheebert explained this to me. It's because a lot of the faux Arduinos, they don't use really high-quality solder. And you get cold joints that over time they'll just start not working. We also need our WS2812s. I got myself a nice big pack of these because we love it.
Yeah.
These are 5 volt, and you can tell if you look, these are higher density than the ones that you've got. Notice how the spacing is.
Yeah, they're pretty close together.
They're very close together. These are more expensive. I mean, this roll actually costs about $36.
All right. How long is that? Probably like 16 meters?
This is a what, 5 meters?
Oh, okay.
It's 5 meters, but I think it's 300 lights.
Ah, okay.
And the reason why I did that is just because, if you want a bit more intensity, you go with higher lights. You're just going to pay more for it.
Yeah.
I mean, here, put this next to the one that you've got there, and you can see exactly how much more dense it is. I mean, if you see the one that you've got in the picture frame, it's like every inch or so. Whereas the one in the roll, I mean, you've got, 3 per inch.
Yeah, no, this one's a lot denser.
Yeah. But denser also means that it's going to use up more power.
Oh,
and it's going to
okay.
be more expensive, right?
Good point.
Just FYI, because you've got 32 lights there. I believe this will probably get it up to 90 lights.
Yeah, so that would really light it up.
Yeah, just FYI. The other thing that I'm going to do is instead of going with that little U-back, because I've got so many lights in this particular case, I'm going to go with something a little hardier. So I'm going to be using this. This will get it down to 5 volts. It's a much bigger device, but this can also provide a whole lot more power than those little ones.
Right, and if anyone remembers the quadcopter segments we've used those before, haven't we?
Yes,
Yeah.
yes. Whenever we want to give clean power to the radio system or to the receiver, these are what we use. So that's all we need, basically. You're going to need a soldering kit. You're going to need, something, a little box of heat shrink because you want to insulate everything. An Arduino, lights, and that's it. This is a super simple project.
Yeah, you've got your soldering kit here. Which one is this?
This is the Yihua. It's like a knockoff of a Hako, which is what Smitty suggested I get. This is nice. So I've been using this for a while. Yeah. It's completely digital, so I can dial in exactly what kind of temperature I want.
That's nice.
It also has a rework station, so I can use this to reflow, or particular what I use it for is just for heat shrink.
Right.
So go ahead and show them the code, and I'm going to start getting this ready.
Okay. Well, if you take a look at my screen, I've got the Arduino IDE up, and it's pretty straightforward as far as the code goes. I first wanted to just test out a few colors and see how well the light was dispersed onto the canvas of the picture. So when you're first starting, this is just the fast LED library that's included with like a lot of the other projects that we've done on this with these Arduinos, and it starts with the include fast LED.h. And then I defined the number of LEDs, which was 37, and that went along the whole border of the picture frame. And then I had to designate what pin we were going to use as our digital, which is pretty familiar for anyone who's done these projects with us or followed along. And we chose pin 7, which this project is a little bit more important because we actually soldered it to straight to the pin. So you'll want to make sure to get that right. And then I just have my setup with the LEDs, the type of LEDs that we use, the WS2812s, the pin, and then the number of LEDs. This is the little loop setup right here. And
people should remember, the reason why we're using a library is because otherwise we would have to program all of that. We would.
Right.
Let's remember the way the WS2812 lights work. You create an array. You fill that array with the values. The values would be the light. What kind of color do you want? What kind of intensity do you want?
Right.
And then you push that array down the string. And every light will take 3 bytes for red, blue, green, and then it will pass off whatever's left to the ones down the line. So if, let's say, for example, you had this where I've got 300 lights and you only give it enough values for 100, the last 200 will have no value.
Right.
They'll be dark.
Right. And
Yeah.
With the WS2812s, they're individually addressable, right? So if I
Correct.
wanted to just do a certain segment of them, I could call those out and
Precisely.
do a color. Yeah.
Right. And what you would do, let's say you wanted every others to be on. What you would do is you would just create an array, and every other value would be empty.
Right, that's right. So as I work on this project, I'm going to tweak the code a little bit so that there's maybe white LEDs at the top and then dark blue LEDs at the bottom to kind of match what the picture looks like. But going back to the code, it's just a simple fade in, fade out loop, and it fades in and out of certain colors. And so if you look at the first one that I have here, 0x0d and then comma 0xff comma 0xef, that is I think that's the hexadecimal code for teal. And then there's white, which I have in the comments, and then blue. And these are the different hex numbers for those colors to be called out in this fade in, fade out loop. And then once it gets to the blue, it just cycles back to the teal, and then white, and then blue, and just keeps going in and out of that loop there.
We should mention that you could just type red or blue or green.
Yeah.
But this gives you much more finite control. You can actually have shades of red and green if you use the hex numbers.
Exactly.
It's just like programming the old style HTML.
Yeah, it is. And I think I wanted to use teal because it was just a little bit different than the blue, and just kind of test some of the colors and how it came out with the onto the canvas.
Let us remember that anytime we're going to be doing insulation, you always want to put the heat shrink onto the wire before you actually solder.
Yeah.
We've done this.
Oh, yeah, I've done that. I've done and then you have to cut the wires and do it all over again. Yeah.
So let's not do that. All I've done is I've stripped these because I want to give myself a standard JST connector. Now, I can give this any value, any voltage between, I think this is going to go from 6 volts all the way up to 18 volts, and it's always going to give me 5 clean volts out of this end. So again, this is a really nice piece of kit to have because I can vary the voltage, but my lights will always be getting 5 volts, and my Arduino will always be getting 5 volts. And you really want that, because if you have a variance in voltage, that's when weird stuff starts to happen.
Yeah, and then you start blowing things up if you're putting too much voltage into things, and
We've got experience with that.
You hear little screams from the LEDs.
But you know what, Brian? That's all learning.
Yes, it was learning. That's why, like with the heat shrink, I did it once, and I was so upset with myself that it hasn't happened again.
Yeah, but I've done it way more than once. I mean, and because I do those late nights in my lab.
Yeah.
And typically when I get tired, that's when I know I have to stop. Like if I do all the soldering and I'm like, oh, the heat shrink's here. Well, it's like, no, I'm done for the night.
I think the reason my experience was so memorable is because I know the exact project was I was working on the Cyma drone, and I was attaching a new motor to it. And it had the really thin wires, and it took a lot of time to strip the wires, hook them up together, and then I was like, I didn't say... I said fudge. I need to put heat shrink on this. And so I cut it and I did it again. And then you walked up behind me. You're like, why don't you just solder straight to the board? And
it happens. Now, let me point this out. This is typically the way that I join. What I'll do is these are twisted together, but it's in line. And the reason why I want to do that is because when I flow the solder onto that, that's going to give me the strongest possible joint between these two wires. In fact, the wires on either side will break before the solder joint does. Some people will do this. Actually, I used to do that where you just twist them together.
Oh, yeah.
But that's messy, and it actually leaves a really like a weak point.
Yeah.
Right there. So I don't do that. Just take it and barrel them together, and then I'm going to put them into my helping hands. And remember, folks, we love our helping hands because they keep everything together without us burning our fingers. And once I got it here, remember, we want to flow a little bit of solder onto the iron so that the heat transfers a whole lot better than it would. And we're applying heat to the wire and not to the solder. We ultimately want the solder just to flow into the wire. We want the wire hot enough that the solder will just go in there.
Right. I know when I first started, I was always tempted to melt the solder onto the tip of the soldering iron and then just kind of wick it onto the wire.
Which will kind of work, but it's not strong. So this is, and remember, you don't want too much, because if you put too much, you end up with a big, huge blob of just unfun stuff. But that's actually going to be really strong. That's not going to break. And then I just take my little
despite what you may think, like, oh, there's never going to be a lot of stress on this wire, it's just going to be hooked up to something. You know, you work on a project enough and you move it around. All it takes is one time to yank on a wire and it gets stripped out, and you're having to do it again.
And it's that learning. That's when you learn. You're like, okay, I'm not doing that anymore. This is the heat shrink that actually has adhesive on the inside. So it's going to waterproof this.
Ah, that's very cool.
And the only reason why I'm doing that is because I'm probably going to have this in areas that are going to be slightly wet. And I want to make sure that I'm not going to short out.
Yeah.
So there we go. That's going to be one connection. What else do you got in the code?
So after that, let's see, what do I have in the code? Because it was a pretty copy and paste sort of deal with the loop, and then I just configured the different colors, and then this is the fade in, fade out loop here that you could do the red, green, blue. This is like calling out the different colors.
And by the way, folks, you don't have to copy off the screen. We will make all of this code available in the show notes, so you'll just be able to download it and then upload it to your Arduino.
Yeah. Well, let's see. Maybe I'll change some of these parameters and see what I type in.
How would I make it red?
Yeah. So you think if I just delete these three values and type in red, it would change it?
It depends what
can you see it?
using. Yeah, I can see it. Try it. I'm not sure. I'm not sure if that particular function is set up to use colors, but
we'll find out.
Worst case scenario is it doesn't work and you re-upload.
Right. You can't really break the Arduino with bad code, right? You just make it sad.
You can, but you'd have to be really talented or very unlucky.
Yeah, one or both. You know,
or both.
At the same time, huh?
See, it doesn't
red is not declared in the scope. Okay. Well, good to know. I know I have like a cheat sheet, Alex. If you go away from my screen for a second, there was like a color code cheat sheet where you type in, you basically write in the color that you want.
And then it gives you the hex.
Mm-hmm. Hex code for colors.
All right, so I've got my connector all set up. So I could plug this into one of our little 1,000 milliamp hour quadcopter batteries, and this will give me a nice clean 5 volts out. In this particular case, we've got a power supply that's already set up with a JST connector. So as long as I give it 5 volts or more, it will be able to give me 5 clean volts.
So you can hook that up to a battery now too, if you wanted to make it modular and
this
stuff.
This is all ready to go. So I could now be portable.
That's cool.
Yeah, we like that. Oh, by the way, people have asked what this is. This is actually just a ferrite choke. What it does is it keeps high frequencies from basically coming out of the power supply.
Yeah, okay. So that's just a little magnet then? Or?
It's just a piece of iron, basically.
Really?
Yeah. It does work. I kind of take them out because they're big and clunky. But if you are having trouble with noise, that's a really good way to choke it out.
That's really neat.
All right. Now, when we hook up the Arduino, we are going to need a couple of things here. So we need to give the Arduino 5 volts. I can either give that through the USB port, or I could give it through the voltage in pins, which are right here. So up top, I've got voltage in and ground. So I give it 5 volts on voltage in, and I give ground is my ground wire. I also need 2 wires to go from the Arduino to my lights. One is ground and one is the digital pin. So it's the one that's actually going to be pushing the data down the line. In this particular case, I'm just going to, because we're kind of pressed on time, we're going to power the lights with this, because this is the one that's going to give us enough power to power the lights. And then we're going to power the Arduino with the USB.
Cool. Right. I like it.
All right. So show me your lights.
Well, let's see. I just need to find those numbers because I can't change. Let's see. I mean, X, F, E, F. I guess I could just change a couple of these and see what. So I can change that to, let's see, white. And let's change them all to white and see what happens. Whoops. So So what should happen is if I change them all to white, it just won't change the color, but it'll keep oscillating in and out with the different loop there.
Right.
So set the Arduino into debug mode. Verify the code. Upload. Little green bars going along. And what should happen with the LED lights is they all just stay the same color, but fade in and out.
Give it time. It's got to upload. Okay.
And give it a sec. And those LEDs should fade in and out if you go to the picture. They're just stuck.
You may need to power cycle it.
Yeah, maybe I'll take it. Let's see. Oop. Oh, here. That's right. We have it plugged into an external power right now.
By the way, folks, when you buy these strips from China, because they all come from China, be careful because they don't always use standard colored wiring. I've seen ones, horrible strips, where they'll use black for the voltage in and they'll use red for ground. So what you want to do is just look. If you look really closely, I don't know if you could get this, Alex. If you look closely, they actually have 5-volt ground and voltage in. So just make sure that you are soldering to the right ones, because if you put voltage backwards on this, it actually will kill the strip. Just, FYI.
Just kill the strip.
Just kill the strip. That's no good.
Yeah, speaking of killing things, I don't know what I did to the Arduino.
Arduino's, I can see it blinking red. It's very not happy right now.
Yeah, what's going on, little buddy? Maybe I'll unplug him again. See, this happens with projects sometimes.
Well, that's why we're doing it live. This is a Let's Solder episode of Know-How.
Right. And whenever you put a project on a live camera, it just doesn't want to work.
Right. You know what? Let's go ahead and take a break right now, because we're going to get back to this. I'm going to have to solder this together so I can get power into my LED strips. But Bryan, one of the things that I did when I was in Rome, I got to drive those little cars, the tiny little ones.
Like the smart cars?
Yeah.
Yeah, I bet that. So in a city like Rome, it's probably the streets are really narrow?
Super narrow, and it's incredibly hard to park. And the fun thing about those smart cars is, even though they're small, they're actually, they've got a ridiculous amount of electronics in them.
Really? I had no idea. I've never been able to drive one before.
They're fantastically tricked out. And I was starting to think, because here I drive a Toyota Corolla, it would be nice to be able to get that kind of information. In fact, the one that they signed to me, it when we pulled into the lot, it linked up with the access point that was in the garage, so that it would tell, like, the minister, was there fuel in the car? Did the car need service? It was, it was kind of cool.
That's awesome.
I thought, wouldn't it be nice if I could get that kind of smarts in my old
in your
Toyota
old Corolla? It would be nice, but how would you do it?
I would do it with automatic. Now, automatic is a way to turn your old clunker into a smart car, into a connected car, into something that is high-tech and wonderfully connected. Now, this episode is brought to you by Automatic. It's a small adapter that turns your clunker into a smarter, connected car. Automatic has launched the Automatic Pro. It's their new 3G car adapter with no monthly fees or subscription, but it means that you're always connected, or it's always there. 3G lets you know when your vehicle is parked at any time, and it lets you track your vehicle even when you're not with it. It works with IFTTT. That gives you endless customization. You can connect your car to the rest of your life, and you can easily file business expenses with popular apps like Concur and Expensify. You can even link your car to a Nest thermostat or Amazon Echo. Imagine being able to say, Alexa, where did I park my car? And Alexa tells you exactly what street it's on. Yes, you can do that with Automatic. It also lets you get human help in a crash. Automatic Pro detects severe accidents, and trained responders will call for help when you can't. Automatic works on nearly every car made after 1996, as long as you have that onboard data port. And it takes just minutes, literally minutes, to connect your car to your iPhone or your Android device via Bluetooth. Plus, it even integrates with Apple Watch and Pebble. I've been using Automatic in my Corolla because I like to be able to know, well, how am I driving? Am I driving efficiently? Am I getting good fuel economy? Is my car doing well? Is my engine okay? And with Automatic, all that data gets uploaded to my phone, and I can check later on to see what my driving habits have been. Now, here's what we want you to do. We want you to try Automatic. Automatic Pro is normally $129.95, but when you use our exclusive offer code TWIT20, you'll save $20 off your purchase price. Visit automatic.com/twit for more information, and remember to use the code TWIT20 to save $20 off the regular purchase price. That's automatic.com/twit We thank Automatic for their support of know-how. Okay, Brian, so what's going on with your little Arduino over there?
All right, so you know how I was like, I changed the code and then the LEDs weren't working?
Right.
I diagnosed the problem as the power cable came out of the board.
That's the ONN OFF discriminator.
Right. And so you know how we were talking about being careful with your solder and everything? It is one of the tricky things about the Arduino Nano is when you solder directly to the pin ports,
right,
those are connections that if the wire bends back and forth are very susceptible to breaking off. Yeah, which is what happened.
Want me to fix that?
Could you do a little emergency?
I'll emergency solder, so I just need to get this back onto the... Oh, Brian.
Oh, poor little guy.
Poor little guy.
It's because I've been dragging this picture frame around back and forth from home, working on it at work, and then bringing it back home at night. And I guess it couldn't put up with it any longer.
Also, when we did this in Vegas, I'm pretty sure we were drunk. So
is it that bad?
Yeah.
Yeah, we didn't really give ourselves much of a lead on the wire there, did we?
We did. This is why you always want a service loop.
Yeah. You should always assume that there's going to be a problem and you're going to need a little bit of extra wire.
All right, so we're just gonna tack this in. But yeah, you're right. I mean, this is why I like to breadboard, because breadboarding is much less susceptible to just breaking off.
Yeah, exactly. So that's why I should have, I mean, when we did this whole soldering to the Nano project, is just attached it to the picture frame and really kind of just locked everything in, because it's been just floating outside of it.
Let's make sure that's actually there, and then I haven't bridged. Okay, yeah, you're good.
Cool.
So now you should be able to show them your code.
Cool. Let's see. Now, just carefully.
Now, one of the reasons why I put the bullets on that is we ran into this problem with the Aquavase, where if you leave it connected to the UBEC, and it's one of the cheaper Arduinos, it actually starts pushing power back into the UBEC.
Oh, is that bad?
It can get really hot.
Ah, okay.
Yeah. So that just gives you a quick way to be able to disconnect power while you're programming.
Well, the nice thing is that I was able to, because of the bullet connectors, I was able to just disconnect it real quick and hand it over to you without having the whole LED strip and everything.
Hey, Brian, you know how I'm sick?
Yeah.
You know you do stupid things when you're sick?
Yeah.
Like, for example, what were we just talking about?
The heat shrink? Nuh-uh.
I totally just did that.
Well, at least you can use sick as an excuse. I mean, I just do that normally. Yeah, and I'm not sick at all. Just make mistakes.
So it happens. It happens to everyone, folks.
All right, so I'm going to change my code here and see. Well, let's see if it lights up. It should pop up here in a sec. Right?
I still see it flashing red.
Let's see. Maybe I'll just... Ooh, it's hot.
Oh. Okay, unplug that.
Hot.
It's trying to draw power back through the UBEC.
Really?
Yeah.
Oh, should I plug it in to the power external power source?
Give it external power.
All right. External power.
Now, the other nice thing about doing the wraps the way that I do is it's very easy just to reflow the solder and just pull them apart so you don't have to cut.
Okay. That's nice. It happens. It happens. At least you didn't solder it backwards, like when we were doing those switches.
That was fun.
Yeah. I remember somebody was, I think, watching the video later and was screaming at their screen.
Right.
Like, stop!
Don't do it! Don't do it! It happens, folks. It's okay. So do it. Did you blow up a Nano?
I might have blown up the Nano.
That's okay, because we can do this. Here, you know what? Program this one.
Okay, we'll see what happens. Get out of here.
This is why we've got a toolbox full of Nanos, Brian. You can blow up all you want, and I'll make more.
All right, I guess I'll just upload the code. But how are we going to hook it up to the LEDs?
I've got them right here. Hold on.
Oh, wait, what's happening? I guess it... Now they're lit up.
Okay.
What's going on here with this little Arduino? I think it got jealous when I brought out the other Arduino.
It's like, oh, I thought we were cool, bro.
That's weird. All right, well, this one's got my LED programming on it. Let's see what happens if I try and upload it again to this little guy. He's so angry at me right now.
Well, thanks for two-timing.
I kind of am, but...
I thought we were cool, bro.
Hey, if you don't perform, you will be replaced. Have you seen the, the Rick and Morty, the little butter robot?
Oh, yeah.
Somebody actually made that.
What?
And he's like, what is my purpose? To serve butter.
Oh, my God.
Oh, my God.
I know, right?
Arduino, your purpose is to...
Oh, by the way, when I was in Rome, I saw pictures of the Halloween party. And Carly's Cora costume from Tron.
Spot on,
That
right?
was spot on.
With the wig and everything.
Mm-hmm.
I think she uses the costume stuff as an excuse to buy new wigs and stuff so that she can...
She
dress up
really
for
likes
things.
wigs.
Yeah.
I mean, and you know what? That's cool.
Yeah.
I buy really strange things.
You don't buy... you know what? You should start getting into wig collecting.
Okay.
That would look good on you if you had a Cora wig for most of the episodes.
I'm gonna say this because we're bros and I love the know-how audience.
Yeah.
I tried doing a Tron outfit about 2 years ago.
Right.
And let's just say how it has those lines on the sides of the costume.
Right.
Mine were decidedly curved. That costume does not work if you're fat.
Oh, you're more of a rotund.
I was bloatware. I was a bloatware program.
That's mean, but it's pretty funny.
It's very true. It's very true. I mean, I was so pumped up because I had the electroluminescent working.
Literally pumped up.
I was pumped up, and then I was like, "Oh, it looks horrible."
Aww. I know. Okay, so as far as the costume with Carly, the one thing that we had decided on is that she should have had LEDs lighting up, the sides of the costume.
Well, naturally, yeah.
But we ran out of time, so she didn't have that, and you weren't here.
I wasn't here. I know. I'm sorry.
Yeah, I think this Arduino might have died, Padre.
Oh.
Not sure what happened to it. The LEDs are coming on, but they're staying the one color, and the Arduino's just blinking at me.
I think it's angry with you, Bryan.
Does it please you to see me suffer?
That's okay. I've got this new one. So here, go ahead and program this.
All right.
And remember, when we do a programming of an Arduino, we also need to set the pin.
Right.
So what pin is the output going to, so that I know where to solder that. So in your programming, what pin are you setting the data to?
In my programming, it is set to pin 7, data pin 7. So let's see. Just make sure to check it real quick. Verify everything. Yeah, should be good. And then upload to the little Arduino.
Now, all of these strips, on the other side, there's typically a connector that is the opposite of the connector at the front.
Right.
So if you cut it off, you can actually do a quick connect.
Ah, smart.
Which makes it a lot easier for you to solder in.
Nice.
Yep. So what I'm going to do on this one is I'm actually going to have the UBEC is providing power to the strip, and then it's also going to be providing power to the Arduino.
Perfect.
Yeah.
Well, so here's the Arduino loaded up with the code. So just set them there.
So what pin do I have to connect to?
7.
7?
Well, I could change it.
No, fine. No, we'll go 7.
What's wrong with 7?
It's 7.
Yeah, you're right.
Oops.
Yeah.
Okay. What you don't want, though, is you don't want to pull out the wire.
Oh. That's okay. You left yourself enough room to... Oh, no, you didn't.
That's what happens when they're cheap. Man.
Will it fit back in there?
No.
Oh.
Oh, man. Folks, this is why you should never buy stuff from eBay.
So how much did you pay for that strip then?
It's like $36. I mean, because there's so many WS2812s. It's all about the density.
Density of it.
The more dense it is, the more expensive it's going to be. Oh, jeez. Yeah, seriously, this is really, really horrible pins. This thing just came apart.
Oh. Well, I guess you don't need a quick disconnect then.
That's a little sad, but all right. So what I'm going to do is I'm going to go ahead and give this power, and then I'm going to connect to digital pin 7, and then we will be able to power this up, and I should be able to control this entire. Now, one thing is, how many LEDs did you say?
I
did you put in
said
the code?
37 LEDs.
Okay, so there's way more on this. It will light up the first 37, though. That's good.
Well, I can always adjust the code to reflect. If you want to just take this length of LED.
I lost the cable.
What?
I lost the cable.
Oh.
Where did the cable go?
Which cable?
The little green.
Oh, the one that you just pulled out?
Yeah, the one that pulled out. I was going to put it back in. Oh, there it is.
Oh, there it is. Underneath tools there. So you could just take this strip of LEDs and measure it out against that.
By the way, I am like, I can barely hear anything that I'm saying.
Let alone what I'm saying. Padre, can you hear me?
Like, no, I can't.
Oh, man. So how do you think you got sick? Airplane?
On the airplane.
Ugh, gross.
There was a woman in front of me who just was coughing the whole way over.
Yeah.
I'm like, oh man.
So did you get a cookie? Did they give you a hot cookie?
No, I don't fly first class when I'm international. I don't have
just
that.
when you go to Maker Faire with me?
Well, because they upgrade me automatically.
Well, of course.
Also, because that was fun. Hey, I offered you. I was like, hey, do you want my seat? And you're like, no, I'm good. I'm good where I am.
Well, you did bring me back some whiskey, so I do not hold a grudge.
Since when?
Well, maybe a little bit of a grudge, but
okay. I'm assuming that red is going to be voltage in. If it's not, I'm about to blow out another Arduino.
You know what happens when you assume with those wires?
I get blue smoke.
Yeah.
Oh, there we go.
There you
See
go.
there. Now it's working. So wait, what did you change? Why is it suddenly working?
So I think what I needed to do, because I have been using an external power source with this, I needed to upload the code to the Arduino and then let it kind of do like a little boot cycle. Because if you look at really closely onto the Arduino, there's a little red light that blinks, letting you know that it's doing what it's supposed to be doing. And then once I had uploaded the code and then disconnected it from the external power, and then basically plugged it back in, it seemed to like reset itself. So it's working now, but I think maybe you soldered the ground and the power really close to each other, because they're kind of.
Oh, are they touching?
They might be touching a little bit.
Blue smoke. Blue smoke.
It's okay. These little Arduinos are pretty hardy. So I'll see if I can change the colors and then re-upload that to them.
And I'm going to go inside of this and then you'll be able to work with a whole new strip.
Cool.
Now you thought about like using these to make lighting in your kitchen.
Yeah, that's what I want to do, and then incorporate one of the PWM switches that we have so that I can kind of brighten it or dim it as needed, and probably hook it up to a switch too.
That's pretty awesome.
Yeah, because I think these would be perfect if they lined the top part of my cabinets and then kind of reflected off the ceiling, or because there's that adhesive backing on a lot of these, just stick them underneath the cabinets or inside of cabinets so you can see where the dishes and stuff are. The
house that I was living in, they had this really cool indirect lighting system where it was basically like a cupola. Yeah. And then it shone light up.
Oh, that's cool.
And I'm like, yeah, that would be kind of nice. I'd love to build that.
Yeah, and I think if I did that, I would also want to incorporate maybe like a music system into it or something, and then have the lights start changing colors if I wanted to play music or something with them.
All right. So if you look here, I've got voltage coming in, and I've got my ground. I'm assuming white is ground, even though that's a really weird choice. And then my green wire here is supposed to be the digital pin. So that's you said pin 7, correct?
Correct.
Now, if I screwed up and I connected it to a different pin, you would just change the addressing inside the program, and we'd be good to go.
No problem. You know what? I'll probably leave it at 37, and then we can show that it won't go the full length of the wire.
No, that's assuming that this works.
That's a big assumption at how this project's been going.
I know.
All right, so
I'm like in a fever dream over here right now.
So I finally re-uploaded the code, and I got it to work so that I'll show it over on the painting over there. Here we go. So now what it's doing, instead of cycling through the blue, teal, and white, I just changed the hex numbers in the code, uploaded it, and now it's just cycling through white. So not as exciting, but that kind of shows how you can change the number and
and I mean it's completely customizable. So you choose the colors you want. And I mean, you can use the entire palette if you really, really, really wanted to.
Yeah, I mean, I could even throw in. It's a pretty simple loop. It's the rainbow code. Just disconnect the power.
I need power.
The rainbow code, I think, is like one of the easiest ones you could do. It's like a little loop that displays every color and then as it goes around.
Okay, so actually here, if you look at this, the nice thing about this is I can put this pretty much any voltage that this particular regulator can give, and it's giving me 5 volts out. The power is going into the strip, and then I'm pulling power from the strip to give 5 volts to the Arduino. And I've got that. I've got power, I've got ground, and then I've got the green one, which is my digital pin. And as you mentioned, you only did 37, so notice it goes. If you bring the lights down a little bit, Alex, it goes up to here. And then it stops, and that's basically it's only the very first 2 feet of the strip. So if you wanted to, Brian, could you program this to say light up the entire strip?
I could. I just need to know how many LEDs are on there.
300.
300.
300.
It's over 300.
Here.
Sure.
There you go. See, and now, quick disconnect.
Oh, look at that little guy. Hey, that's pretty clever. All right, cool. So I will.
Oh, by the way, while you're doing that, go ahead and program that. This little kit that we're gonna do a thing on a know-how on this. This is what I brought to Rome. Basically, this is like a self-contained fun kit. It's got all the quick connectors. It's got a couple of Arduinos. It's got relays, buttons, and LEDs. The nice thing about this is it's I've got 10 of these things. So whenever I go out, I just grab one of these boxes and I'm good to go.
Yeah, it looks like it's kind of like a little Arduino Maker Go kit.
A little fun land.
Yeah, like I'm going to go on a trip and I need to make stuff, so I'm taking you with me.
Yep, just grab one. Although the problem is I deplete the parts and then I just grab the next kit, and then at some point I'm going to start grabbing kits that don't have the parts I need. So,
all right, I'm changing the code to 300. Setting the little Arduino into upload mode. Uploading the code. And in just a few seconds, it should have the updated code, and all of those LEDs over there will light up.
Indeed. Now I can give power to this, but without an Arduino, these aren't going to light up. So you can see the little UBAC.
And that's just because it's not receiving any data then.
Yeah, because it's on, but
right,
it's not receiving any commands to light up.
Cool.
But if I plug this in, the second I plug it in, it's now
all the LEDs.
Oh, Brian,
it's pretty.
It's so beautiful.
It is amazing the effect that you get with LEDs.
You know, it's weird because we've done some really fun projects, but we always go back to LEDs because LEDs are just, I mean, they're cool.
They're cool, and no matter what you really do with them, they'll make things better. Like when I'm doing a review or something and I put them behind a wall, or I have them just kind of shining on something, like it's nice to have that extra bit of color. And look, now they're fading in and out on the colors.
Look at that. Oh,
yeah, going from white and
Brian's
stuff.
getting tricky with this programming. Although I will say, yesterday I saw the use of LEDs that was not good.
No?
I was doing the rehearsal for a wedding that I'm doing on Friday, and they put LEDs behind the crucifix.
Oh.
And so, like, it'll turn the color of the season. And I'm looking at that going,
No. Actually, I think we've been conscripted to do a project for behind the gear.
We're doing that.
Yeah, we're going to put LEDs behind the gear, and then I think the window clock over there, and we'll see what kind of effect we can do when we have a bunch of these LEDs kind of hooked up back there.
That's why I bought these.
Oh, really?
This is going to be going back there.
Nice. Yeah. We got to put it back there and see what it looks like.
Well, folks, we know that this has been a lot of information, and we want to make it very easy for you to do this project because, again, we're into sort of the Arduino 101. This is a very basic project. We've got all the code for you. We've got all the parts. We've got places for you to buy supplies. And where are they going to find that, Brian?
They're going to find it at twit.tv/KH. And not only will you find the show notes for this episode, you'll find prior episodes that you can follow along. So like we had mentioned earlier, we've done a bunch of other Arduino 101 projects. And if you feel overwhelmed with whatever we did today, you can always go back through those and find maybe a more basic one. Although this was pretty basic today when we got it working.
Well, you know, we're just back. We're kind of getting back into the rhythm.
It's true.
I'm ridiculously sick right now. This is a nice one just to chill.
But that's how dedicated you are, is that you still showed up and forgot to put the heat shrink on.
Yeah.
When you,
and I've infected the TNT set. So
yeah, so I'm probably going to be sick next.
Yeah. Don't forget that we also have, we've got stuff in the socials. If you just go to Google Plus and look for Know How, we've got over 10,000 members in our Know How group. It's a great place to find projects, to ask questions, or if you're a bit more of an expert, it's a great place for you to give your knowledge to the upcoming generation of makers and DIYers. Again, just go to Google Plus and look for Know How.
That's right. And if you want to know what we're doing outside of Know How or what Padre was up to while he was in Rome, the best place to do that is on Twitter. I'm at Cranky_Hippo.
And you're going to find me at Padre SJ. And we actually have a third member of our team.
We do?
We do. He's a good guy.
Yeah, he is.
He is, right? He is. He's a little cranky. He's a little grumpy, but he's a good guy.
We all are. Yeah.
Folks, of course, we're talking about Alex Gumpel.
Excuse me, Padre. It's pronounced Alan Smithy.
Alex, I'm sorry, what?
Alan Smithy. Yeah.
Did this happen while I was gone?
His name has always been that.
Okay, Alan Smithy, and you're going to find him at ANELF3. That's Twitter, at ANELF3. And go there and send him a message because it bothers him to no end. Until next time, I'm Father Robert Balliser with a 102-degree fever.
And I'm Bryan Burnett.
And now that you know how,
go do it. Go get sick.